Okay, here we go again. Thread sheet calculation, threading improvements by myself. So here we're looking at one specific spreadsheet to try and optimize. And in this particular one, start off with measuring it. Flame graphs, as mentioned in the last few talks. In this particular case, as always, wider is worse. We want to make everything narrower. And in this one, I have searched for you pre-thread mutex lock, and they're all highlighted as a kind of a pinkish color at the top there. So this is the thing that's taking up most of the time in this particular calculation, 40%. We want to try and reduce that as much as possible, but it's a locking issue. And because of it, we're not getting full advantage of the threading. We're spending most of our time waiting on the other threads that are all waiting on each other. So basically, we've gotten in our own way in trying to do our calculations. What shows up on one of the wide bars there is this particular function of get format, blah, 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 blah. So what matters is that looking at these calc threading things is that we've got SE interpreters. They're created a lot, they're created quickly and they're thrown away, so they're all pretty lightweight. And then we got longer-lived interpreter contexts, one for each thread, which are reused. So you've got a pool of these and they're reused and handed out and reinitialized regularly, but they're long-lived in their own sense. What we really want to happen is we want the interpreters run simultaneously without anything locked. We don't want any of those mutexes to appear. But we've got a single number formatter that's a single one per document, and all of the cells may reference this number formatter. And it has to assume that the number formatter is assumed that multiple things may write to it, multiple things may read from it, and it has to take a lock if you want to read or write anything to it. So that's our shared thing that is the problem. But it doesn't actually do a whole lot, this get format thing. It just takes two numbers and returns another one. Hopefully, we're assuming to start off with that it should return the same thing each time, or at least for the duration of interpreting the formulas, which is the bit that we're interested in. Quick and dirty look at it shows only actually 4 different combinations of arguments to it for this particular document. Looking at similar cases, we find that we already have a per interpreter context cache of the last query, so we can do the same thing for that again. We do that, we put in the cache, we measure it again. Again, highlighted with purple is the p-thread mutex. We have very, very, very little pink, purple, whatever the color is, in that anymore. So we've reduced our lock, and it's down to 4% as opposed to 40% of the time. That lock that remains, this particular spreadsheet is a Monte Carlo simulation spreadsheet, which uses random numbers, which is SC random. We have a single random number object in LibreOffice by default, which again has to be shared between multiple threads. So again, the mutex appears, less of it than there was. What you can do is you can put a number generator into each one of those interpreter context instead, and you can initialize that from the global one. So you have, different random numbers being generated, but you don't have the same contention anymore. And now we have no mutex visible at a kind of a macro level here. So success that direction. Look at that bit more fine-grained, because what we've ended up with is like long bars with very little detail, very little things being called for them. So a lot of activity is taking place in the actual bar itself. So if you look a bit closer down into it, what's that time being spent doing? We can see here in the blue highlighted ones, we're spending a lot of our time in this intrusive pointer thing. Let's at least find out what that does. What it turns out it does is that we're creating a temporary object just so we can search for the existence of an entry in this map. So a lot of our time has been taking up just creating a temporary object just to see if something that matches it is in that. That's a well-known issue in C++ 14 that they brought in an extra feature to manage just this issue, and you can use that extra feature to search in that map without having to create a temporary one. Put that into the mix as well, and that improves matters. The actual number formatter itself, if we didn't have to have this cache in the first place, if we got rid of that and we had a read-only number formatter, we could set it into read-only mode at some point during interpreting, not write to it at all, make it impossible to write to it. If it was the case that we did have to write to it in some way, perhaps we could write into per interpreter context cache of some kind, and perhaps merge them at the end. Let's see if that's possible. Investigate what the number formatter does. Anyway, it turns out you can break up the number formatter into 2 or 3 different parts, and you can run it read only for the purposes of interpreting without requiring the variable part, and run it like that. It's a long process, but the results are that if you had no threading at all, you get that number there for whatever, 20 runs of it. If you ran it before I went anywhere near it, you get this initial threaded contention number, which is higher even than the non-threaded case. The final results of what's been done, as described in the last few slides, is this number at the end. So we've gone like from 15 seconds to 3.2 seconds. I run this crash testing thing, which has got 650 blah, blah, blah documents in it. Was 3 days, now it's a day and a half. So it's possible that these things are unrelated, but the timing is a bit suspicious. So I'm going to take that as my win. There's more work that can be done. That's where the time is now spent. It is possible to reduce that number. If we do reduce it further, then the final number is 2.5 seconds as opposed to the current 3.2. So more improvement possible. Thank you.